Hello everyone, I hope you have seen the previous video I uploaded in this series because we are going to be implementing all of these stages now in this video, and I've already explained and read through what's required of us in the previous video and explained what we are going to do and how we are going to do through this sequence diagram. So you should look into that the previous video. I have made some changes to the sequence diagram. I won't show them to you right now, but I'll keep referring to it all the while implementing the code for it. So we will see everything, and the simple changes like I'm returning OK now, returning OK, and I made some changes to the flowchart as well. So this reading the data and caching and applying the commands should be happening in a loop. So made some changes. I'll refer to them later. Check out for the link in the description. And so yeah, let's just dive into it and write the code for it. So I told you uh, that whenever we receive a multi command, we'll be setting a transactional context to true and initializing a queue. So we need to add these variables in my client class. So let's just do that. So here's my client, and this client now needs a private boolean transactional context. All right, and it also needs a public queue of string arrays, and this is the command queue. All right, and for each command there will be a response, so we need a list of string to store the responses. Yeah, and I'll call it transaction response. And since the transactional context is private, we need a getter for it. Public boolean get transaction context, and it returns the transactional context. All right, it's just a simple getter, and these variables will be initialized in the setter. So instead of calling it the setter, I'll call it public boolean begin transaction. All right, and if the transactional context is already true, we'll return false because we cannot start another transaction. And if that is not the case, we'll just set transactional context to true. And after setting the transactional context to true, we can initialize the transaction response as well. Transaction response is equal to new array list, and we can initialize the command queue. There is a typo, let me fix that. And command queue is equal to new linked list. And after that, I can return the transactional context. Okay, and this method will begin the transaction for us, but I also need a function to commit the transaction or to end the transaction after committing or rolling back. So I'll just call it end transaction, and transaction, and what I'll do is I'll set command queue to null. I'll set a transaction response to null, and so I'll not set the transaction response to null because after ending the transaction, only then should I return the response. So that's fine, because whenever we begin the transaction again, it will be reinitialized to a new linked list. So that's fine. And then we can set transactional context to false. And this doesn't need to return anything. It's a void method, and we'll just end the transaction here. In addition to this, if you see down here, we have some methods that send data back to the client that is connected to the server. So we have these methods, this send method and this send method. So this send method is accepting a, so I'll change that later. That's it for the client right now, but we need to make some changes to these send methods as well. We'll add another send method actually. That's it. I can add that right away. Yeah, let's just add that. So it will be string, and I'll write data dot get bytes. Data is not equal to null, and data dot is empty and not is empty. Only then should I write back to the client. All right. If you realized, we have this DTO, right? And this DTO has a string response and a byte array data. Now we have this send method, and this send method is accepting a string response and a byte data, and we can replace that with a response DTO actually. Response DTO res, and res dot data, sorry, res dot response is not null, and res dot response, and instead of equals this we can do is empty, and output stream res dot response dot get bytes, and this data is also going to come from res dot data, and here also res dot data. So wherever we've been using this method, we'll replace that soon enough with this method, because and remove this because it's not required. We already have a DTO that already has these two things, so it's a bit cleaner that way. Okay, and now let's think of the entire problem bottom up. We'll make first the changes to the store method, to the store class, sorry, and the store class. See, we here now, I talked about it in the previous video. We are going to be locking our primary data store, right? This hash map. We need to add locks for it, and we need to do that in every method. So I'll create the lock first. Let's call it a private final entrant read write lock. Let's just call it read write lock is equals to new entrant read write lock. And in all the getter methods, I should do a read lock. So we don't have, yeah, we have this get keys method, right? So instead of doing this, I should try to do this, and finally I'll unlock. So here read write lock dot read lock dot lock, and then finally I will read lock dot read lock dot unlock. So the same pattern needs to be done in every getter method. So let's just copy this. We have another getter method right here, right? So in this, so let's copy this and get down to the getter method, paste it right here, and add a finally block to the catch right here. And similarly, we should be doing the same thing right here, and I should be locking it first here. So now my getter methods have the locks, And now I need to add the locks to the setter methods as well. The setter methods need to feature a write lock. So it's almost the same thing. Dot write lock dot lock, and here I will paste this finally block and I'll unlock the write lock. Let's just copy this, paste it down here, copy this, paste it down here. Now all my methods I think have the lock. This has the lock, this has the lock, this has the lock, this has the lock. All right. And okay. So see, need to change that as well. It's not really required. It will by default return null. Just, just I like to write it. So now here I need a method that will execute the transaction on my store. All right. So I'll call it a method execute transaction. All right. And this execute transaction method will take a client for which the transaction is being executed. All right. And let's just leave it right like this right now. So we need to execute a transaction for this client. That's what we need to do here. So let's just add the cases for the multi in the master TCP server. Okay, so now we need to do a lot of changes right here. Okay, so first of all, now all my commands are being handled the same way through this switch case. But that's not what we want now, because some commands are transaction commands and some commands are not transaction commands, and some commands will be out of the transactional context. All right. So right here, if my client dot get transactional context, if the client is in a transactional context, we need to do something else. And in both these cases, we need to do different behavior. So if the client is in a transactional context, let's just do early return type if else cases. If the client is not in a transactional context, in that case we need to run this switch case for the command that is being received. Let's just refactor it and write it out in a different method. I will refactor and extract method. The hell, let's just cut it out. And I'll call that method public case handler, and this case handler will take a string of command and a client. All right, and what is it gonna return? We'll return a new response DTO of res and data, and response DTO. That's what we will catch here. Response DTO is equals to case handler of command and client. We got the response, and now here the method that we added will be used. See, we added this method and I'll use this method now. Client.send the response DTO. I'll send the response back to the client, whoever is connected to us right now. Let me think of the order in which I need to send. Where is it? So first we should send the response, and only then should we send the data. Is that being followed? Yeah, first we need to send the string. First we need to send the string and then data. First we need to send the string and then data. Okay, so now back to the master TCP server. Now all these changes need not be done in the slave TCP server because slaves don't, we are not adding transactions for a slave. Okay, so if my client is not in a transactional context, the command will be handled how the same way that it had been handled. So, but if that is not the case, and if we have a special command, I told you that we are going to handle the exec and the discard commands differently if the commands are not exec or discard. So in that case, we need to queue the command. So I need to check if the command is an exec or discard command. So I need to add a check here. If not, I'll call it is transactional control command. So exec and discard commands can control the transaction, and we'll check if the command is that through this method. I will add this method in the master TCP server, and in here the only thing I need to check is if the command being sent down is exec or discard. So instead of sending the entire array, I'll just send 0 down, and in here I will switch on the command, and if the case is exec or discard, in both the cases I need to return true, and default value should be false, and I can just return it. Yeah, so this method will tell us if the command is an exec or discard command or not, and if it's not an exec or discard command, I've added a not here. If it's not that, in that case we need to queue the commands. Now I've already added the queue in my client, and all I need to do is add the command to the transaction. So I will create a method called add command to transaction, and I'll pass it the command and the client, and I will create this method. And in here all I need to do is add the command to the queue. All right, so client dot command queue dot offer the command, and now I'll show you what I changed. So if that is not the case, we just need to queue the command and return back with an OK, right? This is what I added, and this is what we're going to write now. Client dot send. We just need to send an OK serialized in the not OK, sorry. I need to edit it. It should be queued. Let me show you that. Queuing commands. So whenever a command is queued, we return back with this queued. So I just need to add that here, client.send, and it is serialized in the RESP simple string format, and that looks like so. Queued and then /r/n. And since we are sending, it might throw an error, so we need to mark the method so that it can be handled. All right, and right here, if none of these is true, we get into the else. In here we are in the transactional context, and the command is a normal command. Here we are in the transactional context, and the command is a transaction control command, which is exec or discard. Transactional. All right. So, sorry, I've written the opposite comments. So in here, the command is a normal command, so we're adding it to the queue. And if it's a transactional control command, we need to handle cases for exec or discard separately. All right. So I'll create a method called like we have a case handler, I'll call a transaction handler, or let's call it controller. And I'll pass it the command and the client. And now I will create this method. That's all that this method will be doing. In this transaction control method, we just need to add a switch case for exec and discard. All right, so we just need a switch case for command of 0, and if the case is exec, we need to do something, and if the case is discard, we need to do something else. All right, but we have missed something. In my case handler, the control comes here when the transactional context has not been set to true, when the transactional context is false. But when do we turn the transactional context on? We turn the transactional context on when we receive a multi-command. So multi-command is kind of a normal command. It just starts the transaction, but it should be handled normally, like we've been handling other commands. Because the transaction starts only after receiving the multi-command. The multi-command is processed like a normal command. So in my case handler, the control comes here only when the client is not in a transaction. All right. So when the client is not in a transaction, it might receive a multi-command. And if the multi-command is received, we need to begin the transaction. Client dot begin transaction, and we need to return with an OK. That's what the multi-command do. When we receive a multi-command, we return back with an OK. Let me show you that. When we receive a multi-command, we return back with an OK, and an OK in res symbol string looks like this. Let's get back to the code, and res equals to this. This is what result should be equal to. Now, if we receive an exec or a discard command when we are not in a transactional context, in that case, we just need to return errors. All right. So let's add cases for them. Case exec, and in this case, response should be equal to error exec without multi and followed by /r/n. And similarly for discard, all right. I hope you understand what I'm doing here. These three cases, it's pretty simple. If you're not in a transactional context, the multi command will begin the transaction, and if you're not in a transactional context, the exec and discard command should result with an error. Okay, and all right, now let's get to here. We'll first write the code for the discard because it's quite simple. Now let's look at our sequence diagram. If the command, if we receive a discard, we just need to set the transactional context to false and set queue to null, right? And return back with an OK. That's all we need to do here. And I've already done that in a client.endTransaction method. And here I can do a client.send of OK. The transaction has been rolled back successfully. That's what that OK means. All right. So now in my exec, control only comes here. Control only comes here when we are in a transactional context. And if an exec is received in a transactional context, we need to execute the transaction to completion. But there are some special edge cases. If exec is sent right after the multi command, that means an empty transaction. If exec is executed soon after multi, it returns an empty error. It's empty array. So that's what we need to do as well. So how can we check if the transaction is complete? If the transaction is empty? It will be denoted by the size of our queue. If the queue is empty, that means the transaction is empty as well. Dot command queue dot is empty. If the command queue is empty, it might also be null. Client dot command queue not equal to null, and it's not empty, and it's empty. If if it's null or empty, in that case all we need to do is return an empty array. So that looks something like so. An array starts with a asterisk and the size of the array, and then a slash r slash n. That's it. And here we can end the transaction we were in. Client dot end transaction. And since our queue is empty, that would mean that our response array is also empty. All right. So whenever we end the transaction, we should be whenever we execute the transaction and then we end the transaction, we commit it, we should return back the response array. But in this case, the response array is empty because there were no commands to process. So we don't need to do that right here. I can just simply return. So I told you right here, we need to make a copy of the queue in a local variable, and it will be used to trickle the commands down to read replicas. So let's just do that right now. We'll copy and then trickle them down to the replicas. All right. So a copy can be made like so in a queue of string arrays, and it's commands equal to new linked list, and it should be client dot command queue. And after everything is done, we should propagate the commands down to the slaves. While not commands dot is empty, for each command is equals to commands dot poll. For each command, command to propagate, for each command, we have already written the code for it, I think. So yeah, right here. We just need to calculate the resp array and send it down. Command to propagate, command to propagate, command to propagate. What does this propagate method do? Calculates this again. Why are we calculating the resp array again? Because we need to add the bytes that are being sent down to the axe. That's why. Okay, so after this, No, we should do it before. This should only happen when we end the transaction, right? After we have ended the transaction, we can send the commands down to the slaves, and this will be happening on different threads. So it's safe to call this to write this while loop here. It won't block our thread. And now we need to calculate the array that needs to be sent down to uh, the client, whichever the client which had started the transaction. So we need to calculate the resp array for it. Resp serializer dot resp array, but we do not have a resp array for client dot uh, transaction response. See, we have added a resp array for a string array, but not for a list. So we'll add for a list as well. Okay, we will make the required changes soon enough. This will have calculated the response that we need to send to the client. So we'll just send it now, client.send a response. All right. And now right here, we need to do the execute the transaction actually. So before doing that, let's just complete the resp array method. So right here in the resp serializer, see this transaction response array will already have strings that are in resp format. The strings will be in resp format. We just need to make a resp array out of it. All right. So back in my resp serializer, along with this, I should add /r/n, and instead of length, it's size. And instead of adding these, because this method expects the strings to not be in resp array, but I'll add to my transaction response already in the resp array format, so we don't need to do this. All right. Sorry, we don't need to do this. We can add all to the result array. We just needed to add this first, and replace insertion with the bulk collection dot add all. Yeah, and we need to, since they are already in resp format, we don't need to join anything with the /r/n. We can join everything with an empty string. I'll show you what I mean when I run the code. I hope resp serialization is clear enough to you now. If not, I think you should read the docs and try to write serializers and deserializers for resp serialization protocol. It's not that difficult, it's just simple string manipulation. I'm not going to focus a lot of time on it. So back to my master TCP server. Here we need to execute the transaction. Now let's look at our sequence diagram. All right. So I told you something in the previous video that in case we need to delete a value, in case a value needs to be deleted, we need to mark it to be deleted, right? We need to mark it somehow, like a boolean flag or something for the value. So let's just add that first. In my value class, let's create a boolean. Should these variables be public? Absolutely not. Should you create getters and setters for it? Absolutely yes. Am I doing it right now? No. Should you? Yes. Is it the best practice? No. But is it easier and faster to record videos this way? Yes. That's why I'm doing it. You should not. So I just created a flag variable, flag to delete after transaction, and by default I'm setting it to false. By default I'm setting it to false, and now let's get back to the master TCP server. Here we need to execute the transaction. Now executing the transaction is the interesting thing that I learned, something new, and I'll show you what I mean. So we created a method in store class that executes the transaction, right? Here we haven't written the code for it, but at least we have the skeleton for it. Right here I just need to call that method, but to do that I need to inject the dependency private store, and down here I can just store dot execute transaction, and this execute transaction expects a client, so just send down the client. All right, but we need to tell my store how the transaction is handled, how each command should be handled, right? But I don't want that code in my store class. I want that code in my command handler class, because this is the class that handles the commands. All right, so to do that I need to pass a reference of that method into the store class, and we'll do that using functional interfaces. Is this required? Absolutely not. Can you do it in another way? Yes, you can. I'm just doing it to try something new so that I don't forget. Uh, See, I told you I need to write that method in my command handler, right? So in my command handler, we'll create a method down here, and I will call it get transaction command cache applier. All right, this is what I was talking about in my sequence diagram, this transaction cache applier. All right, now this method will return a reference to another method, and a reference to another method can be done using functional interfaces. So right here I need to return another function, and this function expects a command. Okay, and see, let me think. See, this command cache applier is going to apply this command to a temp store, this one, right? So I need to pass in the temp store as well here. So this temp store is gonna be a map from string to value. I'll call it map, and it will return a response in string format. So a functional interface for a method like this is a by function. A by function is a function that takes two parameters and returns one. So it takes a string and it takes a map of string to value, and it returns a string. All right, so that's the method reference. That's how we can capture it in a functional interface. Okay, so right here we just need a switch case for the different kind of commands that can be processed. Command of 0, Okay, so the case might be we might get a set command. All right, we can also receive a get command and a anchor command. So can there be other commands that are part of a transaction? Yes, absolutely. But CodeCrafters is only going to test our transactions with these three commands. So we only need to add support for this, and I'll call string res. String res, and I'll return result instead. All right. That's what we're going to return here. And in case in case we receive any other command, we will return with an error code, unknown command, command of 0 plus /r/n. Can you add support for other commands right here? Absolutely, go ahead, I encourage you to do so. But that's not what's required of us, so I'm not doing that. And in my set and get and incur, I'll create methods for that. To do what's required, I'll do res equal to handle set command transactional, and I'll send it the command and the map. All right. And I'll call it get, and instead of set I'll call it incur. I'll create this method. I'll create this. I'll create this method. I'll create this method. Okay, so now let me tell you something else. This cache applier needs to read data from the primary store because we need to cache it into the map that I'm passing it, right? I need to read from the primary store and cache it. So I need the dependency of store here. Okay, but since I'm going to be passing this method around, see this function is returning another function, right? So since I'm passing it around, I need it in my closure of this method. So to do that, it's quite simple. I'll just create a final store variable and call it local store, and it will just be this dot store. And I'll also need a resp serializer to serialize all the responses. So resp serializer, I'll call it local serializer, this dot resp serializer. And if I pass these local stores and serializers to these commands, they will be wrapped up in my method closure. That's what I need. I don't need to inject these again and again. I just need to wrap them in my closure. If you don't know what closures are, you should study about it It's a pretty important topic, especially in functional programming. If you are a JavaScript handy, you would know that. Uh, but if you don't, you should. If you're a JavaScript developer and you don't know, shame on you. Let's just make the code a little prettier. So now the references of these serializer and this store is now wrapped up in the closure of this method. All right. And I just now need to write the code for the set and the get and the incur methods. That's all we need to do now. Okay. So in my let's first write the set method because it's quite simple. All we need to do is set some value into the uh, cache in my local cache store, this map. All right. So we need to store it against a key, and that key is in command of one string, not string. We'll create a value. All right. New value is to new value and command of two local datetime dot now and expiry is local datetime dot max. That's the new value that we need to set, and I just need to do map dot put for this key and new value, and this set method will the response for a set method is okay, simply like this. That's it. That's the entire code for set. So now this response will be returned to this res. Now this res will be returned to my master TCP server right here, and I will add that to my client dot transaction responses. So that's what will be in my client dot transaction responses. And now I can let's now write the code for the handle get command in transaction method. All right, so all we need to do here is get a key from my primary store and cache it in my local store as well. So that any future changes that might happen, I can do that in my local cache and then dump it to my primary like we have discussed. So I just need to get the key from the command of one. That'll be the key. And let's now create. So it may be possible that the key that the client is trying to get is already in my local cache. So if that is not the case, only then should I go to the primary store. So first I'll check if I have it in my cache as well. Cached value is equals to map dot get or default of key comma null, and if this cached value is null, I'll get from my primary store, which is why I have injected local store into this method, injected passed to it whatever, enclosed in a closure with it. So value store value, and I'll just call it local store dot get value for the key. And now if this store value is null, if store value is null, I can return local store dot get of key, and that will be null. See, control will only reach here when both the values are null. So I can return basically null here. That's what we are doing. And if this local store value is not null, if it's not null, then I need to put it into my local cache as well. So I'll set value to use is equals to new value. I don't want to do changes to the reference that is already in my primary store. So that's why we are creating a new value for it. Because if I put store value into my map and then future commands make changes to it, the changes will be applied to the primary data store as well. And we don't want that. That's why. Oh, sorry, not this. Store value dot val and store value dot created and store value dot expiry, and we can put this in my map like so. But if the cache value was not null, then we can simply return that value to use equal to cached value, and the get command should return resp serializer dot it should be bulk string. Yeah, I have that right. Serialized bulk string value to use dot val. That's what the get command returns. That will be the method. And now let's write the code for the handle increment command. So if you're not sure what I'm doing here, you should read the code in the command handler that we wrote earlier, way earlier. So we have already written the code for get and incr somewhere here. You should definitely read that. Set, yeah, get, and then we have an increment as well. Where is it? Why can't I see it? Yeah, here. So if you're not sure what I'm going to do in those methods, you should know that by now, right? You should be reading the code that's in this class. Let's write increment. So in here, I again need to get the key. This is in command of 1 and string command of 1. And let's again create this value to use. We're just checking if the value is cached or not. Because if it's cached, we just need to increment its value. But if it's not cached, then we need to cache it as well from the primary store into the map. So if it's null, then I need to get it from my value store app dot get or default of key. So instead of not this, we need to get it from my local store dot get value for the key. So if store value is null, we need to cache it, and let's rename to value to use. Yeah, value to use is fine. If it's null, new value, and as I told you, I'm going to be setting the value to 0. and expiry should be local datetime dot max. But if it's not null, then value to use is a new value where the value is store value dot val and created at is dot created and expiry is store value dot expiry. Okay, and after this I can come here. If the cached value was not null, we need to try to increment it. Okay, so value to use is equals to cached value, and we're going to try to increment this value to use. So I'll get the value out of it, and val is equals to value to use dot val. And since we need to increment it, we need to try parsing it to integer. If it's not the case, then we need to throw an error. And I'll try to integer dot parseInt. Integer dot parseInt val plus plus value to use dot val equals to val plus, yeah, parse it to another way to do that is string dot value of for val. And now I can do map dot put of a value to use, and we can return. Oh crap, give me a moment guys, I'll be right back. Here I am. Resp integer of val, and if it was not an integer, if this method threw an error, then the value cannot be incremented. And if the value cannot be incremented, we should be returning an error. Value is not an integer or out of range. All right, that is the increment method code. So yeah, in my master TCP server now, is everything completed in this? I think so. We call this get transaction of command cache applier. This will return a function that can handle get, set, and increment commands for me. And let's just get an instance of it here. Command handler dot, yeah, this. And I just need to pass it to my store method, right? I want to do all this logic in my that's defined in the command handler, and I want to call it right here. So this method also needs to accept this transaction cache applier, and I will pass the transaction cache applier to it. So all this will happen when we receive an exec command. All this will happen when we get an exec command, and in my store I need to use it. Now that's it. So coming back to the store, right here, let me show you the sequence diagram. Now we have an instance of the transaction cache applier, and I am trying to execute it. But before trying to execute it, I need to lock the hash map. Alright, so we can do that with, and the way we have tried to implement it is exactly because I need to lock the hash map, but the hash map locking behavior should be constrained to the store class, single responsibility principle and whatnot. I should not be, this lock should not be a public lock, it should be private static final. And since I can only lock the hash map from this class, it's that is the reason why I'm passing the cache applier to it. There are still better ways to do it, but I chose to do it this way. You're stuck with me. What can we say? And then finally, I will unlock it. And right here, I want to apply this method, right? I want to apply it on what does it accept? This transaction cache applier. It's right here. It takes a command and a map. So I need to pass a command to it and a map. Okay. Uh, and now I know where all the commands are. The commands are in the client.command queue. So while client.command queue dot is empty and this is false, I can pop from it. Yeah, I can pop from it string command client.command queue dot whole. Wow. And now I can apply this method that we created to the other thing that this method accepts is a map. And since my hash map is locked right here, I can now create the local cache, the map where all the data will be cached. Map string to value, and I'll call it local cache equals to new hash map. It doesn't need to be concurrent because only one there is only one client on this thread and no other client is trying to access it. I can pass it the local cache. So for each command now, in the command queue, we are applying this method right here. Right, and we're checking get, set, and incur commands, and we're applying them. Okay, and this method returns a string to us. We need to catch it. String response is equals to this, and we already have a data structure that is storing all these responses, and that's client dot transaction responses dot add a response. Okay, so that will apply uh, all the commands for us on our local cache. But now that all the control will only come here. When the queue is empty, that means no other commands in the transaction left to be applied. And when in that case, we can dump all the data from our local cache into the primary store for entry of string to value entry in local cache dot entry set string key is equals to entry dot get key and value is equals to entry dot get value. And there is something that we added earlier, right? We added this flag to be deleted. So we have not written the code for it in my command handler, but that would look something like so. Right here, if we receive a del command, so what we will do is we will get string key is equals to command of 1 and we need to delete it. So what I can do is get it from my primary store, uh, local store dot get value like so key, and this will be a value of val. Okay, I can create a new value out of it. And the same checks I need to apply here, all the checks that we did for this get method, like if all this logic key value to use cached value store value, so if it's not in my cache, then only then should I try to get it from my local store. But if it's in my cache, what I can do is, let's say I was not getting it from my local store, I was getting it from my local cache, then in that case I would set this to be true like so. Okay, with that my values will be marked to be deleted, but we are not doing that right now. I'll comment it out. uh, let's just write that code anyways, even though they are not asking us to do that. Let's just do it. And del command, I'll show you how easy it actually is. Create this method right here, and instead of doing all this here, I'll basically copy all of this if else logic, paste it right here. So I have cached value. If cached value is null, only then am I getting from local store, and instead of putting it in my local store right away, I'm going to set value to use equals to store value. All right. And if it was in my, if it's both are null, and in that case value to you, we can in that case I think we should be returning an error that we're trying to delete an invalid key, something like this. I don't know what the exact error is in that case, but it would look something like this. But if the value was in my local store, I'll create a new value out of it, and instead of putting it into the hash map right away, I'll put it here. But before I put it there, value to use dot, I'll set it to true, and that's it. And it returns a string, and in this case we should be returning an OK /r/n. That's what we return from this method. So now we are marking the value to be deleted. So now when dumping the value from this, I need to check if it's marked to be deleted. If value dot is deleted in, why is it called is deleted in public, is deleted in transaction, what the hell, I should refactor it. Refactor rename is deleted in transaction, so that should have refactored it everywhere. Is deleted in transaction, is deleted. If value is deleted in transaction, what we can do is I can do in that case I can do this dot map dot remove on the key. And if that is not the case, if it is not marked to be deleted, I'm sorry, if it's not marked to be deleted, then I need to put in my map whatever there was in my local cache. I can put the value here. Hmm. That's it, I think. That is all the code. But instead of adding to the transaction responses right away, uh, I should not, because we are doing this in a loop and a future command might fail. And we may require the functionality where if command fails, all the commands should roll back. And in that case, I should not be adding the response to it right away. What I'll do is I'll create another list. I'll call it responses, new array list of responses, and I'll add responses dot add a response, and I'll do an add all of responses. So what that will do is it will only add to the transaction responses when we are certain that all the commands have passed on my local cache and I have dumped them into my primary store as well. So let's try to run this code now. I hope it works. Let's see. We'll debug if there is an issue. This should be passing. So the build is successful. Maybe my internet connection is slow. It doesn't take this long usually. Okay, so the tests are passing. Yeah, all the tests are passing. I think we are good, and I think I've handled all the edge cases that are required of us. And now all we need to do is just wait and keep clicking continue, continue, continue. So the multi-test certainly passed. So what I'll do is I'll pause the recording now, and all I will do is click mark stage as complete for all the stages. But if I see any issue, any error, I will debug it for you in the video itself. But I'll be back with all the test case passing. Hello everyone, it's a good start of the day because the code we wrote passed all the test cases. We didn't have to change much. Actually, I didn't have to change anything, and we are passing all the test cases. So that's good. The code we wrote is fine, and this should be happening the same for you. You should be passing all these test cases also. And we're just running the last test case. It's handling transactions for multiple clients, and that should be fine for us because we are in a we are running the clients in a concurrent way on separate threads. But anyways, let's just wait and see the logs. All right, so we passed this test case as well, and we passed the extension as well. All right, so woohoo. Okay, so in the next video, I will be dockerizing this application and show you some DevOps stuff. I will try to deploy it on a Kubernetes cluster. I'll run the Kubernetes cluster on my local system using kind, which is Kubernetes in Docker, and we will use Azure pipelines to run agents, and I'll use the Azure pipeline to try to deploy the application on our own Kubernetes cluster, and then we'll Helmify our application We'll use Helm charts, we'll use Argo CD if necessary. Well, it's not necessary at all, but just to learn, just to show you how it's done. And I will also show you how you can create your own agents for Azure DevOps and how to make those agents run Docker commands. And by making your own agents, I mean running them as Docker containers on your own local system. So that's pretty interesting. And yeah, I'm excited about that as well. And I'll see you in the next one.